carbohydrate part 8, we will see the determination of size of the ring. The six-membered cyclic hemacetal structure of D-glucose having a ring of 5 carbon and 1 oxygen atom is proved by following methods. Up till now we have seen the ring structure of glucose, but it is not confirmed whether it is 5-membered or 6-membered ring that is forming the structure of glucose. So the 6-membered cyclic heme acetal structure is proved by following methods, and first method is methylation method. It is also known as Haworth method. Haworth in 1926 for this method. D-glucose on treatment with methanol in presence of HCl forms D-glucoside. So D-glucose reacts with methanol in presence of HCl gives methyl D-glucoside. Then this methyl D-glucoside on methylation with dimethyl sulfate and alkali gives methyl tetramethyl D-glucoside. This reacts with dimethyl sulfate and alkali such as NaOH gives methyl tetramethyl D-glucoside. This structure. Then this methyl tetramethyl D-glucoside on hydrolysis with dilute HCl gives tetramethyl D-glucose, which on oxidation by nitric acid forms keto acid. Hydrolysis of this methyl tetramethyl D-glucose gives tetramethyl D-glucose. This is methyl tetramethyl glucoside, and after hydrolysis it forms tetramethyl D-glucose. This further on oxidation with the help of nitric acid gives keto acid, and this keto acid when subjected to cleavage it may give two types of reactions. First one is C5 and C6 cleavage. This C5 and C6 cleavage, if this cleavage occurs, then we get xylotrimethoxyglutaric acid and CO2. So this part is one product, and this 5 carbon atom containing one part, that is xylotrimethoxyglutaric acid. And if the bond is cleaved between the carbon C4 and C5, then we get dimethoxysuccinic acid as a main product. So a mixture of 5 carbon and 4 carbon acid is formed by cleavage on either side of C5. Therefore, C5 carries the carbonyl oxygen of the intermediate keto acid. Hence, OH group at C5 is involved in the acetal ring formation. The sequence of reaction is represented here as these two products, that is xylotrimethoxyglutaric acid and dimethoxysuccinic acid, are formed by cleavage on either side of this carbonyl, this side and this side. So this indicate that C5 is the carbon which is involved in hemiacetal formation. Hemiacetal means here on C5 which hydroxy group, the presence of hydroxy group, that hydroxy group is involved in formation of hemiacetal or ethereal linkage. And this is the reaction sequence. The formation of xylotrimethoxyglutaric acid indicate the presence of six-membered ring in glucose, that is pyranose ring. If a ring is five-membered or furanose, then the above sequence of reaction will produce dimethoxysuccinic acid and methoxymalonic acid, which is not formed. It confirms in actual experiment xylotrimethoxyglutaric acid has been isolated as one of the product of oxidation. Therefore, the size of the ring of glucose is six-membered and C5 is involved in hemiacetal ring formation or hemiacetal ring bonding. Then second method by which this structure is confirmed, that is periodic acid treatment method, and this was put forth by Hudson in 1939. Ring size of D-glucose has been determined by oxidation of methyl glucoside with periodic acid, that is HiO4. Vicinal diols. Those diols or compounds containing OH group on adjacent carbons. These are known as vicinal diols. Vicinal diols, that is 1,2-glycol, undergo cleavage in presence of periodic acid to give carbonyl compounds, either aldehyde or ketone, depending on the substitutions of the reactants. So here, this vicinal diol, here cleavage is taking place with the help of periodic acid, that is HiO4, and we get ketone and aldehyde. Similarly, these are all examples in which in those reaction sequences we get aldehyde plus acid, acid plus acid. Here aldehyde, formic acid and acid. So it is to be noted that one molecule of periodic acid is used for each pair of adjacent alcoholic carbonyl group. Therefore, by estimating the periodic acid consumption and formic acid formed or formaldehyde formed, the number of free adjacent carbonyl groups in the sugar molecule can be determined. So D plus glucose is completely broken down by 5 molecules of HiO4 to given 5 molecules of formic acid and 1 molecule of formaldehyde arising from terminal primary alcoholic groups. So if this is the structure of glucose, that is alpha D plus glucose, then with the help of the reaction with periodic acid, 5 molecules of HiO4 are required and we get 5 molecules of formic acid and formaldehyde. However, in the ring of methyl glucoside is quite stable. It has 3 adjacent hydroxy groups. It requires 2 molecules of periodic acid and produce 1 molecule of formic acid. This observation can only be explained by considering 6-membered ring structure of methyl glucoside. So 6-membered methyl glucoside, if we consider, then we can explain this all facts. This indicate the presence of 3 hydroxy groups on adjacent carbons, that is 1, 2 and 3 adjacent carbons. This implies that the original glucoside was six-membered ring bonded to C5 oxygen atom. It has been shown on the basis of X-ray studies. It has been shown on the basis of X-ray studies that COC, that is ethyl linkage or hemacetal linkage, bond angle is 111 degree, which is very nearly equal to 109 degree 5 minute. Hence, the pyranose ring should be quite similar to the cyclohexane ring. It should be puckered, and to minimize torsional and van der Waals interaction, D plus glucose should exist in the chair conformation in presence of in presence reference to twist boat conformation. X-ray analysis confirms the structure, and this structure is confirmed. And this is alpha D plus glucose, and this one is beta D plus glucose. When you observe keenly, the difference is only in the situation of this hydroxy group. In alpha, this hydroxy group is equatorial, sorry, this one is axial, and here in beta, hydroxy group is at equatorial position. So, in alpha D plus glucose, the glucoside hydroxy group is axial, that is beta, and in beta D plus glucose, it is at equatorial. X-ray analysis showed that the stable isomer is that in which the large or bulkier group occupies an equatorial position. So, beta D plus glucose is preferentially more stable than alpha D plus glucose. Remember, in alpha axial and beta equatorial position of OH group. Thank you.